Welcome to the first of the Rescale Solutions live webinar series. So this is hands-on with the top science and engineering applications on Rescale, and we're really happy to have you here with us. My name is Jolie, I'm with Rescale, and I will be your moderator. So today's focus for our webinar is on accelerating multiphysics simulations on Rescale, specifically with Siemens Simcenter Star CCM+. So without further ado, we're going to go ahead and get started. We have two speakers lined up for today. The first is our special guest, Carlo Locci, PhD, MBA, Global Application Specialist at Siemens. Carlo graduated in Italy in mechanical engineering, and then he received his PhD at the IFPEN in Paris after working on a thesis on combustion numerical modeling. He then spent another year at the French National Center of Research for a postdoc. And since October of 2015, he's worked for Siemens Digital Industries Software as powertrain and fuel cells application specialist and is based in Nuremberg. And then after Carlo, we'll hear from Stephen Smith, who is Senior Solutions Architect at Rescale. So Stephen Smith is on a mission to provide performance, innovation, and insights to simulation workflows by leveraging the cloud. So with a master's in aerospace engineering, Stephen has a unique 15-year background of applying CFD and optimization to develop innovative products and solutions in a variety of industries. He works as a senior solutions architect at Rescale, where he enjoys the opportunity to bring complex workflows to life in the cloud, which he will show us today. So at this time, I will go ahead and turn the webinar control over to Carlo. Let's see. Carlo, do you see controls?
Yes. Okay.
Fantastic.
Tell me when you see my screen.
I see it.
Okay, wonderful. So, do you also see this part, the GoToWebinar window? I hope you don't. Okay, so let me just introduce our cloud strategy. So modern CFD appeared around the beginning of the 70s and developed following three main paths. The first path that we followed to develop a CFD was computational power. So by improving the computational power and by improving the IT infrastructure, we've been able also to improve our CFD codes and to have a faster and faster CFD code. The second pillar, let's say, to develop CFD and simulation comes from the modeling. What it means it's our ability to look at a physical phenomena and write down equations to describe it. The third pillar is numerics. It means that we look at the physics, we write down equations, and then we think to a way how to write those equations to being interpreted by a computer in a very accurate and efficient way. But the three pillars I just described, let's say, they are for classic CFD. Now we are looking at how the cloud is impacting CFD, and it's a totally whole new dimension. So today I will be talking about how we can drive innovation even more with the cloud by using Simcenter Star CCM Plus and the possibilities offered by Rescale. But why is innovation so important? Let's remember that business as usual is not enough anymore. First of all, we have a very fast pace for innovation. So remember that most of the executives recognize how innovation is really critical to grow a business. And regardless the market you look at, aerospace, automotive, we are really seeing very quickly changing markets. Just imagine what we are asking to the people involved in the transport sector to reduce by 90% CO2 emissions. And of course, we are dealing with more and more complex products. Okay, we have a very different approaches like generative design, additive manufacturing, you name it. So that's why we are forced to use a simulation early and often really to be competitive in a given market. Having said that, let's now dive into the core of my presentation. I would like to tell you a little what is our cloud strategy. So first of all, let me introduce to you Simcenter Star CCM Plus. What is this product? First of all, in Simcenter Star CCM Plus, you have one single window, okay? So no add-in, no plugins, nothing. So you have one single software, and all the things related to the software are in one single integrated environment. Especially important is that we have an automated workflow, okay? So from the geometry preparation to meshing, physics, everything is actually connected together. We also have a very comprehensive multiphysics. Just have a look at the images at the right-hand side of my presentation. Here we have a combustion. We are simulating flows, either the flow of a gas or a liquid. We have a CHT problems for a gas turbine, for a turbine, or even we are able to simulate all the different physics in a car powertrain. Of course, it can be massively parallelized. And what is very important is that right from the beginning, when we built the software, we put emphasis on enabling our customers to perform design exploration. So what happens in Star CCM Plus is that when you change a parameter, for instance, in the geometry, then automatically changes, and then you can automatically remesh. The physics, of course, will behave accordingly, and so on and so forth. Remember that now we are talking about a tool that gives you the possibility, of course, of dealing with the complex geometry, complex physics, but of course, you need computational power to solve those kind of problems. So just to give you statistics, more than 80% of our simulations today run on HPCs. And now let's talk about the cloud. So how the cloud can really favor this kind of simulations, very complex simulations. Here, in a nutshell, we can see our cloud strategy. First of all, we want our, let's say, we want to give you flexibility, okay? So we want you to not have the burden of IT, okay? So you just need to set up your file and send it very easily to the cloud. But also we want it to be affordable, okay? So by using a cloud, we want you to save money. And that's also a very important aspect. Generally, we say that we want to switch from a CapEx approach, okay? So where you have maybe a long-term investment on your cluster, but you want to go towards, switch towards an OpEx approach, so operational expenditure, where basically you only pay for the hardware you need. We want it very simple. That's also fundamental. It means that basically, again, you have a very simple web interface. Once you have set up your file, you have it on the cloud, and you say how many processors you want. And of course, you want to be faster. I will actually talk more about what we mean to be faster, but of course, we want you to innovate more rapidly than you did before. So in our cloud strategy, to summarize it, we want to put at the center the engineering productivity, and of course, as a consequence, having a more agile business. But let me tell you a little more about what we mean by being faster. We distinguish between scaling out. First of all, what it means scaling out? It means that, for instance, you take a given product or that you want to improve, and well, you want to maybe put emphasis on some on some aspects that you would like to improve. But sometimes you have a concurrent objectives. Okay, so you needed to find a optimal trade-off between these concurrent objectives. So with the cloud and with Simcenter CCM Plus, of course, you can simulate simultaneously many designs and then find the best design with the best trade-off among the concurrent objectives. So that was the scaling out part. But then we want the scale up part. What does it mean? It means that you have a very complex geometry again, very complex physics. You need many processors. Ideally speaking, if I double the amount of processors, I want my simulation to be twice as fast. Okay, so that's the ideal scalability. And actually, the good news is that the CCM Plus has really an excellent scalability. Just to tell you that we performed some tests and we achieved 98% scalability, when 100% is of course the ideal scalability, on 60,000 cores. And we still reach a 77% scalability on 100,000 cores. And of course, I mean, we generally, these very high number of processors are used in a proof of concept simulations or in academia. We are not going to use those very high number of processors in industry. Still, just think how well CCM Plus can scale. And finally, before concluding my presentation, I would like to talk about a success story. How Trek Bicycle, they use the Simcenter CCM Plus to optimize the aerodynamics around the bicycle. So before they were simulating 30 designs in a given time, today they are able to simulate 1,000. So just think about the scaling out approach I was talking about. So this is what they declared. So being able to use the power on demand licensing scheme around simulations in the cloud has been of tremendous help for them in terms of productivity. To summarize, well, we distinguish between scaling out, so simulating many designs in a given time, and scaling up, so being able to increase your number of processors. You can do that very easily in the cloud in order to speed up your simulation. I also discussed about our cloud strategy. Okay, so it must be flexible, affordable, simple, and faster. And of course, with Rescale, this is all possible. And finally, let me again put emphasis on, we are very excited about the enormous possibility that a cloud and of course also Rescale can offer. So thank you very much for your time.
Thank you, Carlo. If anybody has any questions for Carlo, go ahead and put them in the chat. It doesn't look like we have any at this time, so we'll go ahead and turn things over to Stephen. Stephen, if you hang on just a sec, I will give you the sharing capability. And thank you, Carlo. Great information.
Thank you.
All right, Stephen, do you see that share capability?
I do now. There we go. Thank you.
Fabulous.
All right. Hopefully coming through the ether here.
We hear you and we see your screen. Perfect.
All right, great. Thanks. Well, thank you, Carlo. Thank you, Jolie, for the introduction. I wanted to quickly just kind of get a high-level overview of the platform before jumping into using CCM Plus on the Rescale platform, just for some context here. So at a glance, Rescale, founded roughly 2011. We're a global computing and innovation platform. So we do not own any of our hardware. We are accessing all the major cloud providers, AWS, Azure, Google, Oracle. We have access to all the major platforms. We're not taking any of our own hardware and running things on our own hardware. We are making a platform on top of that. I'll get into what that looks like in just a second. But suffice to say, there's a lot of backing behind the platform. and we serve a large number of segments as well, from aerospace to public sector. We work on a variety of different workflows on the platform. Let's see here. Change my slide. There you go. Okay, so roughly speaking, I won't go too far into this. I'll jump into STAR here in just a second. But the Rescale platform is just that. It's a platform. It is intended as a way of abstracting the complexity out of loading, running, solving, maintaining on an HPC environment. So our goal is to have a very easy to use way for the end users and the management to access the power needed to run all sorts of intense computations and simulations on the cloud, whatever cloud that makes the most sense for the end user, in a very turnkey way. So that means you're not having to rely on queuing systems, schedulers, not having to rely on maintaining OS patches, installing the software, making sure your MPI settings are correct, et cetera, et cetera. It's a full turnkey stack that is managed by Rescale and supported by Rescale. So if you have support issues, we support that as well. And the end user can focus on the engineering, the big questions, and getting the job done without having to worry about downtime associated with maintenance or deployment or patching of an HPC environment. Okay, that being said, you'll see a little more of this as I dive into the platform. But rough topics, description of the simulation, I want to walk through some pre and post processing workflows, a meshing and solving workflow, including sharing jobs, running Javas, parameter changes, what we call end-to-end desktops, running a large cell count simulation, what are options there, and depending on time, hopefully I'll get into DOE and parametric sweeps and optimizations before wrapping up with questions. So anything that crosses your mind during this presentation, any questions, please put them in the chat window or save them for the end. We'll have 5 to 10 minutes, hopefully, in the end to review that with you. So, welcome to the platform. Let me change my screen here and look into the platform. So I just need to give you guys a basic orientation on the Rescale platform before I can dive into the CCM Plus on it, just to give some context here. So the basis of Rescale is what we call a job. A job is analogous to a batch submission in kind of HPC lingo. It's a way you can submit interactively from a web browser to a cloud resource that we provision for you. The job function is a collection of inputs, outputs, and results, software settings, everything that you've done and run and set up in a kind of containerized package for you. So this is useful for future referencing. If you need to go back and audit why you got a certain result, what version of the software, what commands you run, etc. But as you can see here, within really, we're showing 5 steps. Within 3 steps, you can be up and running on a HPC cluster in the cloud with very little knowledge needed for HPC. You don't have to worry about submission scripts, although we support, as I'll get into, the more advanced workflows where if you want to start doing that sort of thing, we definitely support that for you. So what I want to get into first is, okay, we have a demo job, demo simulation here of a mixing vessel. And I want to pre-process that, right? So I'm not ready to actually batch submit my job yet. I need to make sure my geometry is set up. I need to make sure my mesh settings are set up correctly. And so I'm going to do that through a VDI solution we call desktops. Desktops you can think of as a tangential benefit or add-on to the job, right? So it's part of the workflow. The workflow I show you here is one of many. There are lots of ways to approach a problem on the Rescale platform. And so a lot of it will be dependent on what you want as the end user and what your workflow requirements are. So I already have this spun up, but we have the ability to spin up a desktop where we can launch through our web browser a desktop solution where we can do some pre and post processing of an input file. in this case, we're looking at a mixing vessel. And here we are. This is a clean, no mesh mixing vessel. Now, all this work has been done on getting this set up. We support, you can do this here on this VDI client if you want, or we can connect to that through a license connection on your local machine, and you can transfer that to the platform. Either one of those ways is fine. But the first thing I want to do is I want to go through and take this job, and I'm going to build this up. So the sequence of events for today is I'm going to build up a single job and show you all the different ways you can do that with the intent of increasing complexity to, again, show you some of the more advanced ways you can accelerate your innovation using the StarCCM Plus automation. So as we all know, StarCCM Plus is great. And the fact that the entire tree is automated, you can automate a whole bunch of the whole process just within StarCCM Plus itself. Now for the Rescale platform, we support all that, but let's say I've got this job here. I've set up the geometry for. I want to make a few changes before I run a mesh on the Rescale platform. So I'm going to go in here and I want to look at my mesh operation here. We're in parallel, and I'm happy with the remesher and polyhedral. You know, maybe I will, maybe I'll adjust the base size just a little bit here of my mesh. Look at that setup. The rest of the solving settings I think I'm okay with, but I'm going to save this job. And you'll notice here that I have a folder already set up. Now, I want to take an aside here that with the desktop on Rescale, we have the ability to, remember I talked about jobs being a collection of inputs and outputs. We can attach jobs on the fly to these desktops that they spin up. In this case, I put one I just titled entitled file repository of the platform. I've also got some solutions already loaded onto the platform there as well. And I can add software as needed on the fly to the platform. So I've already connected a job. In this case, file repository is an empty job, which means it doesn't have results. I connected that to the desktop. And when I go to my desktop, just to illustrate here before I save it, everything you need as the end user is right here on the desktop. We have a link to your attached jobs folder. Here's files repository. Here's some inputs I have. I can also manage these things from the desktop as well in terms of the Rescale platform itself. I double-click StarCCM Plus and launch it. In this case, I'm going to save this as a, where am I at? I'm going to put in my file repository. I'm just going to do demo input here. I'm going to save it to a platform. So I've made some changes to a geometry file that I want to process on the platform. I'm going to leave this tab open. All I need is a browser, but I'm going to go back here. I'm going to hit sync files. Now this is telling me what's changed. So I want to sync my files. And what that does is it brings it back to my working folder. So I can go back to my working folder. And if you look at my file repository, you'll notice that here's my file right here that I just set up. So now, okay, I've got my files. They're synced. They're on the platform. I want to create a job here, and I'm going to do mesh mixing vessel. I can name it whatever I want. I want to add this from cloud storage because I already have it on the cloud, but we also support loading from the desktop as well. I have 20,000 files here, so it's a little slow on loading. And this is a good time to point out that the Rescale platform, we don't have a queue. So when you submit a job on the Rescale platform, we're actually standing up the hardware for your job exclusively. That allows you to scale in two directions. Number one is the number of cores for that job. You can use as many cores as you want for that job. And number two is number of jobs in parallel. So you can run as many jobs as you want in parallel with as many cores as you want. There's no restrictions there. And keep that in mind as I build up on this and some of the benefits for that. Now, if I needed a macro here, I'll, in the next step, show you what that looks like. But I'm going to select some software, StarCCM Plus. I'm going to do patch 2 here. We have a wrapper script to identify the input. In this case, I don't want to run. I just want to mesh. So I want to mesh. And so these can be templatized if you don't want to do that. And then you can set your licensing. So we support connecting to your license you have already with Siemens. So through a VPN tunnel or IP forwarding or SSH, you can connect to, if you have CCM suite, power tokens, or POD. In the case of POD, I can access that here in the platform. And we actually automatically save that for you. So once you have input it once, you don't have to input it again. Now, going back to the concept earlier of being multi-cloud, this is a little overwhelming, but this is the amount of hardware you have available to the end user. And why do you have this much hardware available to you? Well, the point is that you need to select what makes the most sense for your simulation. In this case, I'm going to mesh a mixing vessel. One of my go-to starting points is Emerald. Again, we've abstracted everything for you as the end user, so you don't have to worry about selecting OSs, selecting patches, or selecting a cloud. Again, with these 3 steps, it's all you need to run your job. Now, this is a summary of the hardware we're going to run on the left, but let's switch that to nodes and do one node. Say it's 144 gigs of memory. Well, I'm meshing, and typically meshing is a pretty RAM-intensive process with Star. So let me change that to something that has a little more RAM. Maybe I will switch to, what about this one here? This one has a lot more RAM. So this is Carbon. So this is almost 352. Maybe I need more than that. Maybe I have this example file is around, I believe, about 20 million cells. So I don't need to get too much bigger than this. I'll rule of thumb, but say if I needed to, I could go, I could jump on something like Topaz, right? And I can increase the number of nodes, or I can get almost 2 terabytes there. So the point I'm trying to illustrate here is that on the Rescale platform, you can choose the hardware you need to get your job done, which means as an engineer, you don't have to paint yourself into a corner saying, well, I don't have as much fidelity on my CCM Plus job as I want. The mesh isn't as fine as I need, just because either hardware or queue time, I happen to restrict myself. I get to eliminate that. Again, we don't have a queue in the Rescale system, or you as an organization will not have a queue. We stand this hardware up for you right away. So that eliminates a large roadblock in terms of doing things faster and faster turnaround, and also more complexity, right? You can add more physics, you can add more fidelity on your model. So I want to just say, I've tried this before, so Emerald is sufficient for this job. And I'm just going to hit submit. You can do a project tag here if you want to track your costs, but I'm not going to dive into that today. I want to hit submit, and that's it, right? So what's happening now is the Rescale platform is validating the inputs and standing up the hardware for this job right away. And while that gets going, and I'll show you what it looks like in a second, I'm going to jump back to my my desktop and look at one that's already been meshed. So we'll jump back to this in just a second once it stands up, and show you. I want to show you what it looks like when it's all meshed. Here it is, the geometry scene. And so this is the, so this is the mesh non-solution, that's the solution file. This is the meshed file here, as you can see. So I've got my mesh on here. Where's my representation? Parameters. My fingers are too fast for this. So yep, I've got a volume mesh. That's actually, I was wrong, it's around 20 million cells on this representation. So I've got my mesh. Now I need to set it up for solving. And so I'm going to come back here. Typically, you approach this the same way you do on a desktop or another HPC environment, but I'm going to do a couple different changes here. My stopping criteria are set. Those are fine. And on my plots, what I'm going to do is I'm going to enable, Star CCM Plus has the ability to enable hard copy jobs on the plot, or plots and scenes automatically. So I've got that set here. In this case, I'm doing every time step. For that, I'm doing the same thing with residuals. So I want to show you both ways. You can see these plots as they're generated on the Rescale platform. And so that's why I'm doing this. I'm setting this up for that. Anything else I need to set up? I think that's about it for now. And then I'm going to take this job here, and I am going to submit this one. at the same way. So I'm going to save as, and I'm going to call this one, well, this one's already been run, but let's call this one okay. So once that saves, I'm going to sync. I'll come back over here. My cluster is starting, and give it another couple of minutes, and we'll see that come up and live and see how that works. Again, what I'm trying to do here is build the process, right? So we've looked at a geometry. There's a lot of nuance in all this. Go in depth at some future point. But what I'm trying to illustrate here is as we can increase the complexity, and also with that complexity comes nimbleness, with the ability to scale our innovation on the platform. So I'm going to create a new job. And again, I already have some jobs running. I'm going to add one from cloud storage. It's already on the platform. And I'm going to add, let's see here. Here's meshed. Here's a meshed file. Add that to it. That's this file meshed with no solution. I'm going to do a same thing I just did before. I'm going to do all this in parallel. 1502 is fine. And I'm going to change it up. This is already on run. So I'm happy with my mesh. I want to run my solution. Again, we can go back and set our licensing. This is already set, so I don't need to worry about any of that stuff. And then, okay, so again, I can select what makes the most sense in terms of solving. This case, maybe I'll use this core type here. Notice it has a little more RAM per core and a little bit higher interconnect. Unbeknownst to you, this could be on a different cloud provider. It doesn't matter. I just need to get my job done. So let me do a couple nodes here. We can do 3 nodes just to illustrate the point here. And I want to do mixer solving. Submit that. And, oh, let me change that. So that's submitting. Go back to my job. We can see that it's already started my mesh for mixing. And you'll notice by default that Rescale captures everything out of the star command window. So we can see here what's actually going on the simulation. If I needed to, I can SSH into the head node and make some changes if I so desire. But we're not here necessarily to talk about that level of detail. And this is also where you can see one of the reasons why I wanted to output some of my plots and scenes automatically through star. We have the ability to look at that here as the solution starts converging, or in this case, meshing. We can see what's going on with the platform. So I wanted to show those 2 steps just to show you how to start building up the complexity of the platform. Now, I could do something, again, utilizing the tree and the automation of Star CCM Plus, I could do more than that, right? So we can start adding some complexity here. So let's take that same simulation file here. Actually, you know what? This one's meshed. Let's not use that one. Let's have one that's not meshed. Here, that one's not meshed. Add my file, add my software. In this case, I only want to mesh it first before I run it. So again, I'm adding complexity. I'm working my way down the tree of Star CCM Plus. So I want to do both of those because I'm happy with this input. And I'm going to select my licensing. And then I'm going to select my hardware. In this case, maybe I want something that can handle 17 million cells. So the rough rule of thumb for scaling, roughly if you want to scale 25,000 mesh cells per core is roughly where you want to go. And let's look at, well, maybe I have a lot of physics enabled. This is a multi-phase mixing example. and I need a really high InfiniBand interconnect. Maybe my simulation makes use of that effectively. So let's scale that, and let's do say roughly 700 cores, right? So again, the magic of being on the cloud and not having to wait in a queue. This is stood up automatically for me. Again, the end intention of all this is to allow the end user to really do engineering and not have to worry with messing with HPCs or maintenance or queues or any of that, right? We want to focus on STAR, we want to focus on innovating and asking the bigger questions. And so we can do that with the Rescale platform. So I'm going to hit submit. You get that going. I forgot to point out. So we also have this version here where we have a built-in interconnect option here that's proprietary to this cloud provider, HPCX, and it scales phenomenally. So I'm going to select that version. The software is telling me that, or the platform is telling me that. So then I'm going to run and get that up and going on the cloud. Now, coming back here, we'll see that my mixer part is solving. And what you'll see now, you see this temporary decrypt icon. What I'm not going to get into, but everything that we store on Rescale in transit and rest is encrypted. So we at Rescale don't have access to that. So this is proprietary to the user. So what's happening now, this is a large file, right? This was like 26 gigs. This is being decrypted on the fly. So once that's decrypted, it's going to start running on the platform. And I already have one RAM already on my desktop, and that would be this one here. And the solutions you see, again, I'm not, let's see, we can see, what we got here? Check some of my plots here. Solver lapse time steps. So roughly, depending on if it's an inner iteration or outer iteration, between 20 and roughly 17 seconds per iteration. So it took for that one. Residuals, fairly cyclical there. Look at my wall shear stress versus Y+. Looks okay. Let me check, my scene file. Again, I can sync these automatically through attaching jobs. Scene files there. So everything looks okay on this simulation. So what if I wanted to post-process? Well, I could do post-processing here. And what I could do is I could take that job that's already run. So say it's a mixing job, right? So let's take one that's already ran. Let me take this one here that's already run. I can take see if this is a catalog of what has happened on the platform. Here's my process output.log. It's over a meg, so I need to download to look at that. Here's my residual files. Here I can look at, I can download, I keep track, I have it in a separate folder. But here's the mesh file. I want to make that available. I've already done it, but let's make this available as an input file so I can use it for another simulation. So now I can pass one job to another, from one job solution to another, and increase my complexity on that. So let me go back to here and show you guys. So that's decrypted. This is a lot lighter file. You can see it's meshing, and your familiar command window output CCM plus. Let's check on the solver one. And that has decrypted, and it's already started, and loading my modules. And so that will start running here in just a second as well on 780 cores. Okay, so I've done a basic pre-processing, a basic meshing, and a basic solving. Now, let's say I have a job and I have a problem, because a lot of times engineers don't work on these in isolation. I need to share with somebody. Well, I'm going to hit share. If I need to, we can reach out to Rescale support. If something happened, we can help you diagnose. Again, what I said earlier, that everything's private to the user. We are not able to see anything unless you share with us. So if you want to share, you can do that as well. Or I could work on a colleague. So I could do Carlo, and something like that, and I can share. And now I have shared my job with Carlo, and he can look at my results or help me diagnose what went wrong. And we can collaborate on that as well. Maybe he can add something if he wants to, if he modifies this job and adds something to it, I can see that as well. Now, another really, really handy feature here is cloning. So let's say I ran this job, and this job I'm going to clone, and say I made a mistake somewhere. Maybe I'm using a version of the platform that maybe I'm using, patch 1, I need patch 2, or maybe 1406. It's not going to run, it's the wrong version, but let's just illustrate that point. I can change my software version there. Everything else stays the same with clone, right? So I can do something like 06.013, and this is 2000 cores here. Say I didn't need that many. Say I needed maybe 2 nodes on that end. 2 nodes, whoops, hit submit. And just like that, in a matter of a minute or two, I'm rerunning the simulation on an older version of STAR, or maybe I had a parameter I need to change. So I think that is a good lead-in to Java and parameter changes on the Rescale platform. So keep what I said in mind earlier about standing up hardware for your job exclusively and not a cluster that you're submitting to a queue for. That will come into play here as we start advancing and accelerating what we can do with that automated Simcenter Source CCM Plus tree. Now, let's say I'm taking one of these jobs. Let's say it's this one here that I have solving. Yeah, this is great, but oh man, I forgot to change my propeller blade pitch. So I'm going to copy this, clone, and I want to say pitch 45 degrees. Okay, so now we can start making use of some of the more advanced features of Star CCM Plus. Now, this is a global parameter, so I can do something like change my parameter to command line. So I want to say blade pitch, and I want, it's right now at 30 degrees, I want to say 45 degrees on that. So I want to change my parameter right there. Now, this is a geometry change. So let's do a mesh and run, right? So I'm going to change my blade pitch to 45 degrees, all the command line from job that I already have running, and I'm going to mesh it and run it right here. And let's hit submit. And just like that, again, I'm not submitting to a queue. I'm standing out this hardware just for me as an end user. I have a 780 core job running, a 200 core, I think a 200 core job running. Regardless, it doesn't matter. I have everything running. You see, that's already completed there on that end. And I have a parameter change I did as well. Now, we're adding on to complexity. So if you remember, if changing a parameter, I'm doing that right away with basically a click of a thumb. You can start envisioning scenarios where we can start translating. So all this is done for one simulation, right? So one simulation at Star CCM Plus that I'm looking at. Now let's start looking at a bigger picture. Because I can do all this really at the drop of a hat on the Rescale platform, I can start looking at things like parametric sweeps or DOEs, right? Design of experiments. I can start looking at that very effectively. So the automation of Star CCM Plus and the ability not to have to handle at the hassle of handling the HPC or no queue in the background, as you can imagine, is really opening up what I can do as an end user in terms of investigating the what if scenarios, right? So I can start doing well, as Carlo pointed out, one of the missions of Star CCM Plus is to bring simulation earlier into the design. So if I have the ability to not even worry about the hardware, so I'm not constricting myself in terms of the physics selection or the mesh size, that's already taken care of. Plus, I don't have to worry about queue time. Just imagine what I can do is when I start having the ability to just play with parameters. So I could do this manually, as I just showed you guys. I kind of did a manual command where I can change a parameter just in the command line. But let's, we're building a race car here, but we need a driver, right? So we need to drive this race car to accelerate our innovation. And that can be done in a couple of different ways. One thing we can do is in terms of a driver, is what we have is a job type that we call a design of experiments. As you can see here, this starts adding in another layer that the platform has in terms of managing. So now that we have this fully pipelinable CCM Plus job, we have the ability to change the simulation at will and the parameters at will in terms of meshing and running, all that. Now I can start adding in more complexity and start looking at design of experiments or parameter sweeps, what have you. So I already have one set up. I'll show you what that looks like when it's set up. And what we're doing on the platform is we're telling the platform, okay, well, in this example, I have two variables, material density and particle diameter, that I want to vary for maybe I'm looking at sensitivity of the system to this. So I've defined these on the platform. And what I'm going to do is I'm going to have a macro, a Java macro that I created. Here I'm going to look at this on the platform. And the Java macro the platform is going to take these and replace these in the Java macro. So I have this material density variable that I've defined, this global parameter I've defined in CCM Plus, and I've exposed into my Java macro. So I'm going to go here. I can also edit this as well. And I'm going to say, well, I want to find my, So I'm going to find my material, I need to look at this and close because I'm changing things. I don't want to change things. So let's do mat density. There it is right there. Okay, escape out of that. And I am not winning on the, there it is, mat density. Now, this is what the platform will replace in the Java macro, right? So as you can imagine, you can get these macros, this is a fairly complex macro. You can do a lot with this. So the platform is going to change that material property here, this material density for me. Now, again, we can have the platform manage that. If for whatever reason I needed to change something on the fly, I could find that, I forgot what line it was on, but I could find that variable and change it manually here. Maybe I have the name of my scene wrong. Version 2, hit save, and it's already saved. I don't have to worry about downloading, re-uploading, or any of that stuff, and run the platform as well. Then I can just hit run, right? And so the platform adds another layer on top of that in terms of managing these parameter sweeps, managing this automated CCM Plus stack, and allows me to start asking bigger questions. Now that's DOE parameter sweeps and kind of design sensitivity. Now, really, the holy grail and the thing to really take this to the next level is with optimization. And so Rescale supports connections to a lot of different optimization tools. For example, HEEDs. You can run HEEDs on your local machine. Use Rescale as a resource, and you can start adding in complexity of these complex workflows of combining CCM Plus with multiple tools, or just very complex CCM Plus routines utilizing HEEDs. And then so that really gets you to the point where a lot of us that went into engineering and simulation, what got us intrigued is asking these what if and why questions. What if we we have constraints of this nature around the blade pitch? Maybe it's from 35 to 55 degrees, but we can also change materials, etc. And increasing that parameter list that we want to change, instead of doing a parametric sweep, intelligent look at the design space, do an exploration of the design space. That's a whole other topic I'm not going to dive into completely right now, but just suffice to say that the Rescale platform will connect to the HEEDs environment. or multiple other optimization tools, and allow you to drive this fully automated Star CCM Plus model and ask the big what if, why, innovative questions and deliver results that you couldn't do on an on-premise or your typical, even in the cloud, even if it's auto-scalable solution, right? So you can have thousands of virtual prototypes done in parallel in record amount of time, getting better designs faster. And with that, I'm going to pause since I have about 7 minutes left and see. I'm going to stop sharing my screen. Please pause sharing my screen. Turn it back to Jolie, but I wanted to see if we're at the point now where if anybody had any questions or anything in the chat they wanted wanted me to review.
So it looks like we have a question from Brian, but this one may be intended for Carlo because it came right after. So Brian asked, with respect to your scalability example, can you comment on number of mesh volumes per processor considerations? Carlo, it looks like we still have you with us. This was asked right after your
Yes, of course. Yeah, so that's a very, very good question. As a matter of fact, generally, we can push up to 5,000 cells per core. Okay, but that's an extreme. Okay, and generally, I mean, you can also have fairly more cells per core, and that's like, for instance, around 10,000 cells per core. So yeah, it really depends. Also, generally speaking, that's a very complex question, let's say, okay, because it also depends on the physics you are studying. For instance, let's imagine that you have a simple flow, okay, and these kind of configurations, they scale very, very well, you know, linear scalability. But for instance, Star CCM Plus, when we add, I don't know, a Lagrangian solver, then the scalability, it's not exactly linear. Although, I mean, the Lagrangian solver of Star CCM Plus scales very, very well. Yeah, so definitely we have some rules, some rule of thumb, as I said, but also it really depends also on the physics. And generally, we always advise to do some tests, okay? So in the sense that since it's so flexible, by the way, to do a test on Rescale, it's definitely worth to run some tests and to see whether your simulation is scaling well.
Thank you, Carlo. We have another question, this one for Stephen. Thanks for your presentation. How does Rescale secure data at rest? How do you guarantee privacy and security for defense or industrial users?
Yeah, that's a great question that we could spend a whole other webinar on. But suffice to say that we have everything 256 AES encrypted at rest and in transit. The platform has the ability, it meets ITAR restrictions, and also as well, we are federate, moderate, and process. We're hopefully get our ATO on that soon. And we're also HIPAA, SOC 2. We have a lot of mechanisms in place in terms of security. Now, this contrasts to like a DIY AWS or Azure environment or Google or any of those other ones where they provide the bits and pieces, and you as a end user, whether it be your IT department or yourself, have to build upon that to achieve ITAR or federate moderate levels of security requirements. So Rescale already has that baked into the platform. So you already, it's everything I'm doing here, I can do on our ITAR platform as well and be fully ITAR compliant.
Thank you, Stephen. Do we have any other questions? Looks like we're at the end of our hour here. Give you another 20 seconds or so to enter if you have any. We do have one. Okay. So this one says, I have a question regarding running Star CCM on Rescale. For some DOE jobs, assume running airfoils with different AOA. Sometimes a run took longer than the other jobs. The sim file is the same, but some parameters are changed. However, some jobs took longer. I was wondering why. Thanks.
Yes, yeah. Maybe that's a question for me. Yeah, definitely. So that's a very good question. So yeah, it really depends. Okay, for instance, what's happening is that you are changing your geometry, and then you get a very different geometry, and maybe the solver is taking a little longer to solve one single iteration. Okay, so it's just a numerical aspect. And let me add something. That's why we generally recommend to stop your single design simulation, not based, for instance, on the number of iterations, like, for instance, I don't know, 500 iterations each, because that what can happen is that one design totally converged with the 500, whilst another design, well, it was really not converged at all. So we should always stop our job, maybe basing ourselves on some physical parameters, like, I don't know, the velocity, stabilized velocity at the outlets of your configuration. So this is my recommendation.
Great, thank you. Two more questions and we have a hand raised. So we'll get through these two. Do you regard SimScale as your partner or competitor? Thanks again.
I guess that's for me. No, definitely. So it could not be a competitor, because we are talking about a totally different business model, first of all. And then no, definitely they are partners. For instance, there are also some official presentations where we show Rescale as a partner. So no, absolutely not a competitor.
Thank you, Carlo. This one's for Stephen. Can you give some details on the cost of running on Rescale?
Sure, yeah, absolutely. The prices that you saw on the screen are what we call street prices, but Rescale utilizes a volumetric pricing model. And what we do, as you can imagine, we have a lot of customers, and we take the aggregate aggregate consumption, and we go to the cloud providers and we try to negotiate a better rate. And so the pricing that really depends on how much you're going to use in terms of core hours. And we offer discounts based on deposit levels, because we can go with a core consumption in hand to cloud providers. So the real answer is it depends. But if you look at the total cost of running, including Source CCM Plus, there is definitely an inflection point where, yes, you may be spending more on hardware to get your job done, but maybe you'll get it done in 2 hours. But you look at the total cost aggregate, that actually be less in total, including licensing costs, than running for maybe 24 hours at 2 cores on-prem or at a different location.
Thanks, Stephen. Kind of following up on that, I have a question and a hand raised from Ben. So I'll read the question and then I will unmute Ben in case he wants to add to it. He says, the value of Rescale in the marketplace is the ease of use to focus on engineering itself without the overhead of HPC administration. This also translates into a very powerful and predictive pricing model. However, are there financial views to manage budget and forecast cost? And now you are unmuted, Ben, if you want to say anything.
I think you nailed it.
Okay, so Stephen, if you want to address that.
Yeah, we absolutely do. Unfortunately, I don't have the time to show you, but we have a whole administrator portal. I mentioned briefly that we have the ability to tag jobs and projects, right? So what that means for organization is that I can have all my users tag everything I run with a project, and just tagging a project is kind of a trailing cost, but on top of that, we have budgets. So we have a dashboard. I'd love to show you guys at some point. That when users log in as an administrator, you can see what every project is consuming, what they've consumed, what they consume against a budget, if they have a budget. All that information is available to you as the end user, and it's really slick. I apologize I didn't get a chance to show that to you, but yes, that is baked into the platform.
All right, great. It doesn't look like we have any further questions, and our hour is up. It has been a pleasure to spend it with you today. Thank you so much for joining us. We do have another webinar in this series that will take place on Wednesday, May 20th, and then the Innovate from Anywhere Distributed Workforce webinar is on May 27th. So 2 weeks from now and 3 weeks from now. Thank you again, and yeah, have a great day and stay safe out there.